Hello, everybody, and welcome to the YouTube Model Builders Arduino for Beginners show tonight. That's with Chris of MRL Trains. Before we get started, I'd like to tell everybody to go to YouTubeModelBuilders.com. There you can check the schedule for all the shows, the Tuesday, Wednesday, and the Saturday show. Also, click on the eMag and sign up for that for email notification when it comes out. Got one coming out next month, so it won't be long. Don't have to wait too long now. I do want to remind everybody the month of May and month of June, I've had to change the schedule a little bit, and Mr. Barry has made the changes on the website. So just to kind of go over it, the changes for the Tuesday night shows. May the 9th is going to be the fine scale build, and May the 23rd is going to be build the track planner. I had to change those around, so that's the only real changes I got for May and June. So be sure and check the schedules so you don't come in on the wrong night for the wrong show. But if you happen to do that, that's not a problem, or you're working night shift. We do record all our shows, and so you can go to YouTube and go to YouTube Model Builders, and we do have playlists. So check your playlist, get caught up on the past shows that you missed out on. And with that said, I am going to turn this on over to Mr. Chris here. Do this, and you're on air, Chris.
Okay, thanks, Johnny. Thanks for the intro and hosting again tonight as usual. So tonight we're going to work with a real-time clock, which is actually a little board that keeps real time. I mean, I know there's a time function within the Uno, but every time you turn it off or reset it, the time resets. So what a real-time clock chip has a battery on it. It keeps real-time clock as far as seconds, minutes, days, weeks, months, and years, and it even accounts for leap years and things like that on the calendar. So it's pretty handy device. I think that, one thing I wanted to look at using it for was a fast clock, which would be a little bit of a stretch, but I think it's something we could try and do down the road. But if it also has plenty of other uses, anytime you need to know the time or date for something you're doing, you could use the real-time clock, such as building lighting. If you want your building lights on your layout to come on and off at a certain time, or any other, lighted signs or some other animation to come on and off at a certain time of the day and go off at a certain time, you can certainly use it for that. So a couple minutes, we'll dive into that. But just want to let you know we have Chris and Dave with us tonight, and Robert was there a minute ago. He just disappeared. If you're out there on YouTube right now watching us live and you want to get on the panel, we have openings. A couple of the guys are traveling and probably won't be making it tonight. So we do have openings, and if you're just post up in the chat and Johnny can send you the link if you want to get on the panel. So all right, so with that, I'm going to switch my camera and show you what the real-time clock module is. So this is the one I got with my kit. You notice on the back it's got one of those big old disc batteries on it, and on the front, it's just a very small chip when compared to the Uno. And what the pins on it are is it's actually an I2C or I2C connection, just like the LCD display that we did last week. If you have the one with the backpack, it's got the same 4 pins on it right there. This one actually has a few more pins, but it does the same thing. You got your ground, your volt, and your 2 connections for the I2C network. So it's very simple to hook up, as simple as it was with the 4 wires with the LCD that we did last week. So before we get to that, I just want to show you, yours may not look exactly like this. There's 2 common types, and I'm going to start screen sharing to show you the difference between the 2. And they actually function quite a bit the same from everything I read. It's just one is more accurate than the other. This is the other one, the one I didn't show you. It's commonly called, no, come on, computer, DS1307. As soon as my computer catches up to me, as soon as I go live, it always starts lagging on me. But anyways, that one is, as you can see, it's more square, and it's got the same battery on the back side. It doesn't have the pins, but it has the same connections. If you notice where my cursor is, there's ground, there's VCC for your voltage, there's the SDA and the SCL, which are your data and clock pins for your I2C network. That's all you really need to do. The difference is you have to solder, either solder some pins or solder your wires directly to it. There we go. Now it's finally moving. And this is the one I was just showing you. This is called the DS3231. And it, it doesn't matter who makes it. They're all used, pretty much from what I've seen, use that same designation. This one's just a little different because it already has the header pins on it for you, but you can see it's got VCC, ground, SDA, and SCL. These other two we're not going to worry about tonight. For here, it also has a solder pad if you wanted to solder directly instead of using the header pins. Now the difference from what I've read is this one is more accurate. Not that this DS1307 is not that accurate, it's just that it's susceptible to temperature changes that could actually speed it up or slow it down. So, it could potentially be slightly less accurate than this one. This is the one I got with my kit, so any of you guys who bought the kit from Frontale on eBay like I did probably got this same one. Other than that, they work the same. The codes even work the same when we go ahead and program on the IDE. It's going to be the same thing. So any adjustments, if you have either one of those tonight, we're fine. Here's the fritzing diagram that basically shows you how to connect it, and it's just as simple as we did last week with our last show with the LCD. You got 5 volts ground, your SDA and SCL going to analog pins at A4 and A5, which are typically used for your I2C connection. So that's all we really need to do to connect it. Okay, that we're going to get to later, we're going to add in the LCD display like we did that we used last week. So we're going to combine that one with the clock and actually display the time on the LCD. And while this might look a little bit elaborate, it's really just bringing the voltage from each one together and putting it to the Arduino, the ground, the SDA, and the SCL. It just brings them together in one spot on your breadboard and then sends it to analogs pin 4 and 5. The other thing I didn't mention, these will actually run off of 3 volts or 5 volts. And you notice it's got the 3.5 or 3.6 volt battery in it. So, typically all the things we've done on the Arduino, we've been using 5 volt, but this one you could actually use the 3 volt if you wanted to. And you're probably asking yourself, why do we even need to power it? Because there's a battery on here. Well, the cool thing about that battery is once you turn off your Arduino or reset it, you don't have to reset the time. Program this chip with the time, whatever time you want to, typically like right now, whatever the time is when we program it. And then you can disconnect it from your Arduino. You can disconnect your Arduino if you want, or this board. And it'll keep that time as long as that battery has got juice in it. So it's got at least a year, sometimes 2 or 3, depending on the battery. Because a lot of the things you do with this chip, you could also do right in the Arduino using the clock that's built into the Arduino. But the problem with that is every time you unplug it or reset it, it loses power and you have to reset the time. Excuse me. So that's not something you want to be doing all the time. Unless, like I said earlier, if you want to set this up as a real time, as a fast clock for a layout, then you might want to reset it, but you still have that option. It doesn't mean you can't, but You know, anything else you want to use it for, it'll always keep the accurate time and date as long as there's juice in that battery. All right, so just going to scroll through here. There's a link right here, and I'm going to try and highlight it if you guys can see it. Or Johnny, what's the best way I can share this link with them? So what I'm going to bring it up on my screen, but if you wanted to follow along, it's there. I found this website, and let me go to it real quick. I'll switch windows and show you. Off of first tonight, I found this looks like it's something interesting, and you know, once again, I haven't actually done this. I just read about it, and I'm going to try it for the first time live right along with you guys. You know, the good news is, or the bad news is, I haven't had any Arduino time since the last show other than looking this stuff up. The good news is I got my layout done. I got the bench work done, and the main line is connected all the way around so I can run trains now. The show is on Saturday, and after that, it's Arduino time for Chris. Take a break from building layout and start playing Arduino. So the time is finally here. That's the good news for me. The website is Tronic Stuff. And I think if you just go to that website and search the DS3231, you'll find this tutorial. Otherwise, let's see if I can help walk through the menu here to find it. I'm just kind of working through this for a second, but my computer is going slow again. That's probably not a good idea. All right, I'm going to back up because this is going to take me. But anyways, if you guys poke around that website and hopefully you can find it. Otherwise, here it says Tronics. Go ahead, Dave.
I just did a Google search on Tronic Stuff and DS1307, and it was at the very top of the list.
Okay, there you go. Perfect. So, repeating what Dave said, he did a Google search on Tronic Stuff. That's TRONIXSTUFF, and then DS1307, and it was the top of the list. So, for those of you guys who are going to watch this later, I'm sure you're going to want to find this because there's code we're going to copy out of it. So, starting off, it just kind of tells you a little about the difference, kind of like I was explaining, between the DS1307 and DS3231 real-time clocks. There's a picture of each one right there. Here it's telling you what the difference is, basically, in the accuracy. And then they go into explaining how to connect it, which I kind of showed you already. If you get stuck, you can come back and look at this. And then they go into giving us some code. And it's kind of neat because I think it was this website. Otherwise, I got to go back to the other. All right, before we get started. Aha, I'm going to go back, switch back to here and click one of these other links once. Because there's kind of a neat little the guy has that you just set your time and date, load it into the Arduino, then you comment out that at the time and date and reload it, and then you've got the time in there ready to go. So I'm going to check this website and I'll show you how to get there too. We'll do this one actually first before we do the other one. There we go. Slowly but surely it's filling in. Come on, Pokey. I'll have to start a GoFundMe for a better computer for Hangouts. There it is. All right, so if you go to this one is howtomechatronics.com. That's howtomechatronics.com. Tutorials, Arduino DS3231 real-time clock tutorial. There's a neat little bit of code on here that we're going to use first after we set up our Arduino. So if you guys can see that, I'm going to leave this up for a second so you can write down that URL. Either that or just try Googling it, howtomechatronics.com, and then just put in the DS3231. I'm sure this will come up. Page, it'll look like this, Arduino and DS3231 real-time clock tutorial. For a few more seconds, then I'm going to stop sharing and we'll go ahead and actually connect our real-time clock and then come back and load this code and try it out. Questions up to this point in time before we get started? Anybody have any chat comments out in the questions out in YouTube? Otherwise, you know, even if you don't have a real-time clock, follow along. You might learn something. This is what we're here for. So, all right. I think I stopped sharing, right? Okay, and this is recorded for future reference. You can always come back and check on it again. You know, after tonight, you know, work your way through, get a real-time clock if you don't have one, and come back and try this later. So, all right, so the first thing we're going to do is go ahead and I'm going to take a red wire, connect it to VCC pin on the real-time clock chip, and I'm going to go ahead and put it on the 5-volt. I'm going to take a black wire from ground, connect that to the GND pin or ground pin on your clock. Then you can take, I don't know, any color that you want. I just happen to have an orange one. I'm going to go from the SDA pin back and check and see which one it goes to. So looks like the SDA goes to analog 4. So that would be, once again, just like last week, it's the, let me grab my pointer. Here. I had it here. There we go. So the analog pins are the ones with the A in front of the number. So we got A4 and A5 are at the very end right here. Those are the ones we're going to use. So put one on A4. Now take your SCL pin and go ahead and connect that one to A5. When you get done, it should look something like this. Let's see if it'll focus. There it goes. Okay. So now let's go back to the screen share. I'll show you the diagram real quick in case that helps you. I gotta learn to stop saying real quick because there's no real quick with this computer. So back to the fritzing diagram, you can see that's pretty much the same thing. You've got the red wire, the 5 volts, you got your black ground wire from the GND to the GND. And then it's really hard to tell, but this is actually a blue wire they're using on the SDA, and it runs down over and up to the analog 4 pin. And the SCL5 runs to the A5 or analog 5 pin. Hopefully everybody's got that. Now I'm going to switch back to that other website, the Mechatronics website. I'll scroll down to the code. And here again, this website does a good job of explaining what the real-time clock chip is and what it does. This is tutorial for first-time users. It even tells you where to get some, but you scroll down far enough, it says once we connect the module, we need to program the Arduino board to work with the real-time clock. However, when it comes to programming communication between Arduino and an I2C module, the code isn't that small and easy. I think we saw that last week when that code can get just for connecting your LCD. It says, luckily, there are several libraries for the DS3231 real-time clock, which can be found on the internet. So what they mean there is the libraries are like pre-canned code where you load the library and it's got all that code already loaded for you, so you don't have to program it all. I think we've been finding out how handy those libraries are as we work. So once we download and install a library, we can use its first demo example to initially activate the clock of the RTC module. In order to, in the setup section of the demo example code, we notice there are 3 lines that we need to uncomment in order to initially set the day, week, the time, and the data. Is taking out these 2 slashes. Remember, we can put 2 slashes in front of a command and then the code ignores it. It doesn't try to program it. Because they actually have a set of commands that you uncomment. In other words, remove the front of it. And go ahead and get it like here. It says Wednesday. We can change. We can leave that because it is Wednesday. We can set the time to something like 8:30. And then we change the date to today's date. Here it's January 1st, 2014. Well, we will obviously change that to May 3rd, 2017. So once we copy this code and put it into the Arduino IDE, we'll change those things and go ahead and upload it. And then, excuse me. Yeah, so we'll have to upload the library as soon as we get done going through this example. But the one thing you notice down here, it says, you know, it's kind of hidden below this ad. I missed it the first time through, but once we upload this code, we need to comment back the 3 lines and upload the code again. So this is that handy little sketch I was telling you. All we're doing is we're programming the clock with our time and date by uncommenting it, setting it to the time and date we want, and then uploading it. Comment the lines and upload it again, because that what you're really doing after you comment it, all you're really doing is beginning you're doing the library, loading the library, starting your serial monitor, and activating the real-time clock with the RTC begin commands. Let's go ahead and see about downloading that library, which if you scroll just up a little from where I was reading, it says, for this tutorial, I chose to use a library made by Henning Carlson, which can be found and downloaded from his website, www.rinkydinkelectronics.com. So I'm going to go ahead and click on that link, and if you're on this page, I suggest you do the same. And if you're just following along, you could type in www.rinkydinkelectronics.com. That's all one word. See what happens when I click on it. So here's the library. Now we got to find a file to download, right? Okay, so here's our downloadable zip file. Now, if I remember right, it's been a little while since I did a library, so somebody help and jump in and help me out here. But we're going to download that zip file. We're just going to unzip it and put it in a particular folder in the Arduino folders, right? And then that's all we really need to do, isn't it? Dave the Guru, can you jump in and help us out on that? Does that sound right?
Can you repeat that one
You
more
there,
time?
Dave?
Oh, sorry.
Or Chris? So to, yeah, it's, anybody wants to jump in. I'm not looking at my other screen right now. So to load a library, we download the zip file. Like I'm going to click on it right now and download it. Then we unzip it, assert to the library file in your Arduino, right? Which I'll show you when we get there. But that's all you really have to do to
Yeah,
load the
you
library,
have to
right?
put it. There's going to be a folder in your documents folder on your computer called Arduino. It'll be a library folder, and you just extract that folder to that library folder.
So if you open on your file explorer and find yourself the Arduino. All right, where did it go? Well, it's got to be here somewhere. I'll go find my C drive.
Go to documents. I think it's in
There you go,
documents.
this PC. Yeah, there's C drive. Oh, it's in documents?
I think so.
Oh, yeah, there it is.
There it is, right there.
And then there should be...
Libraries. You just passed it.
Yep, there it is. Okay, libraries. So once again, I'll back up just to show you guys. So wherever you've got your Arduino, in most cases, it'll be in documents at the root level. And then Arduino. Libraries. So what I'm gonna need to do now is go back and find, should have went to downloads. So look in your downloads file, find this DS3231. Click it. And then you could, actually I should go back and extract it, shouldn't I? Or I can just copy it to there and extract it there. But so in this case, I'll right click, extract all. I better move it. I'm not seeing the one I want. So I'm just gonna Control X to copy. Back to that Arduino folder. Libraries. Here. Right click and extract all. And then hurry up and wait. There you go. Okay, so that didn't put it where I wanted it to. So I'm just going to cut the whole folder and paste it back in. Oh, it did put it there. Okay. That's weird. So I'm just going to go ahead and delete my zip file since I have it. So should have it in here with any other. These are the other libraries I've downloaded since I installed my Arduino. One of them is the CMRI library, the MRH libraries. I'm well aware what hobbyist where they got the bunch of stuff that Dr. Bunce did, and then there's a new liquid crystal library, which we worked with our LCD display last week. So I'll stop jumping around, I promise. So I'm just going to double click on this, and looks like there is a folder in there, and let's see what's in that folder. Oh, it's just a bunch of other folders. So anyway, we should be good. Any questions on that?
There shouldn't be
Anybody
two
need help?
folders, Chris.
There shouldn't be?
No.
Okay, so I
copy and paste, copy all that stuff and paste it into the root of that original folder.
All right, so what I'm gonna do is I'm just gonna back up here. I'm gonna cut this one out. Go back to libraries. I'm gonna paste it, and it's not gonna like that because it has the thing that I would guess. This is acting weird. Okay,
Just go
now
into
it's
that
okay.
folder. Just go into that folder and then go into that.
It's all good right now. If I open that folder right now, it's got all the.
Okay.
So I basically overwrote the other one, or else it just didn't go away. Maybe the lag in my computer, it didn't. But yeah,
Yeah,
I
it
know
was
what you meant. It looked like it was a
a
folder within a
lag on my
folder.
end.
No, I think I had the lag on my end. Anyways, at the end of the day, and if you're out there on YouTube and having problems, we'll wait for you. We got time tonight. Just post up quick on the chat. And Johnny, are you watching the chat or not? Okay, good. Just let me know if anybody needs help. So you should end up with a DS3231 library under Arduino libraries. And if everybody's good, I'm going to move on. So now we're going to go back to the web page. So I'm going to close this one just to help get some resources back on my computer. So at the Mechatronics website, I'll go back to the top to make so you can see and make sure you're on the right one. So the How to Mechatronics. We'll scroll down. And we're just going to copy this code. And if you look right up here, there's three little tabs. One is open code in a new window. One is toggle raw code highlighter. So you can either just try and copy all this, or you could open it in a new window if it makes it easier for you to copy. But just make sure you get the little curly bracket on line 17. That's the one that always manages to escape you if you're not careful and then your code doesn't work. So highlight it all, copy it to your clipboard. And if you haven't done so already, open up your Arduino IDE so we can start a new sketch. So that's what I'm going to do is just hit new, get a new window, delete all this, and paste in the code we just copied. So now the instructions are right in here, the same as the website. He tells you to, right under the serial begin, it says uncomment the next line if you're using a Leonardo. Well, we're not. But then here's the following lines can be uncommented to set the time and date. So I'm reading that right here. So what we do to uncomment is just delete the two slashes. Whatever you want for your time of day. And today is Wednesday, that's fine. Let's see, according to my computer, it's 8:34 right now. It'll probably be about 8:35 by the time I get done doing this, and it's a 24-hour clock if you read right over here. 24-hour format, so we'll make that
20.
20. Yeah, as soon as I get it, there we go. 20. And then 35, and we'll just leave it at 0 because the format is hours, minutes, and seconds. Just looking at this right here. And the date, we'll make that 5/3/2017. Go ahead and hit save and plug your Arduino in. Check your port, make sure you're in the right COM port that you're used to using. Right now, if you're like me, you've gotten a habit of using the same port all the time, so you don't have to change it. And then if you're all ready, go ahead and hit upload. Hopefully it's only 8:35. So mine is compiling. pretty simple sketch, so it shouldn't take too long to compile and upload. If it hangs too long, then there might be a COM port issue or something else, missing curly brace. Or
I see you don't have
not as with,
you don't have a void loop in there, so there might be an issue.
I see that. I have a void setup and no void loop. You're right. Yep, because that's one thing Arduino requires. Yeah, there we go. It errored on me. So
You might
I'm just
also
going to
want
go
to
ahead.
readjust your time another 2 minutes before you.
So what I'm going to do is I'm just going to do this the easy way. I'm going to highlight all my code and copy it. Sketch, because you notice in the new sketch it already has the void loop in there. I'm just going to get rid of everything above the void loop. Paste that in. The question of, I'm going to close the old one out.
Yeah.
That looks
Could it
good.
not be just in the library?
Yeah.
The only question was, do we still need this curly brace right here? Because when I
Yes,
click
you
on
do.
it,
Yes, you do,
okay,
because
so
that
Dave says
closes
yes,
the
we do.
setup section.
Okay.
Speaking of which, I don't
Welcome, JD.
see an
Heili.
open curly brace at right under setup.
Yeah, because that's why when I click here, it's giving me the box, but there's nothing there.
Right where that box is, that's where the brace should be. Oh, it's there.
Yeah,
The
I was in
box
the
was
box.
hiding it.
Okay, that was hiding it. Very good. So yeah, if you're ever in doubt, going back to a couple shows ago, you just click next to it and it'll highlight a box over partner somewhere. So there's got to be an open and a close for every one of those. So even though there's nothing in the void loop, this should still run, Dave. We don't have to put anything in there, do we? It just has to have that
That is correct.
void loop set up.
Yep.
Okay. So this time, first I'm gonna, before I bother setting the time and all that, I'm just gonna do a verify, because that really does the compiling for you. I need to save it again because I started a new sketch and I forgot to save it. So by compiling your sketch without uploading it, once it compiles and you don't make a lot of changes, it seems to go a lot quicker. No, it's not. Oh, you know what? We need to load that library, don't we? I don't see any command in here to load the library. Do you?
Yep, you're right. That's missing. You need that include on there, which would be include,
Yeah.
and then in the angled brackets, ds 3231.h, and then a close angle
You
bracket.
have to restart the IDE for it to see the library.
Okay.
Because the
So I'm gonna.
program pulls that folder for any library when it opens.
Okay. So what I'm going to do is I'm just going back to this website. Apparently this is not a good sketch, but I figured if he's got more sketches. So here, if you scroll farther down on the Mechatronics homepage, there's another sketch and it actually has exactly what Dave was talking about, your include statement already typed for you. So you can just copy and paste it from there. Need that pound sign in front of the include all the time? Or
Yeah,
is that, yeah, okay.
you need it.
So I'm going to go ahead and highlight that.
Chris, we still have the same error, although the library is downloaded and it shows up in the library list in the IDE. And I've got the include in there. And the way I got the include in there, I just told the IDE to add the library in, and it puts it in the code.
Okay, did you restart your IDE?
Yeah.
Like Chris was saying, it needs.
Yeah, I restarted the IDE.
Test it and see if I get the same results. So I got just copied that. I'm going to go to my IDE. Above the void setup, I'm going to put the include statement to load that library. Now, do we need to start the library after we're including it? But is there something else we need to do?
Flip back to that other
This is a
screen.
good test. Yeah.
You might need that
See,
DS3231 dot. Yeah, that line. Yeah.
this line right here.
Yes. You might need that one.
That's calling. Okay, that looks like that's probably
Doing a setup.
initiating the I2C network
Yep.
or something. Yeah.
You might also need to include the wire.h.
Yeah. Well, yeah, you're
Well,
right. You would.
Where's no? Because if the library can include wire.h automatically.
That is true. It can. We don't know that if for a fact though.
See, libraries
Oh.
can inherit other libraries. It's just that the developer has to include it.
Okay.
That is correct.
And we don't know. So, well, I'm going to go ahead. I'm going to keep this highlighted and we'll come back to it. I want to test out to see if I have the same results. So I'm just adding the include statement to include the library. I'm going to go ahead and save it. Then I'm going to restart my IDE.
Yeah, I think I agree. I think because you don't have the instance of the library that tells it the SDA and SCL lines.
Right.
Because we're using the I2C network, we need to initiate that network.
Yeah,
Right.
that basically starts up your connection. That's all that's really doing.
Right. So pretty much,
Yep.
if you dived into that code for that library, it's probably doing wired up again.
Yeah,
Right.
that's probably true.
All right. So now I'm back to this. You know, it restarted it for me. I'm just going to go ahead and check the compile first. So using my check mark instead of the upload where it says verify, that'll test my code for me before it tries to upload it. You guys are seeing my IDE okay?
Yep.
Yeah, okay. RTC was not declared in this scope. So yeah, let's go back to the mechatronics. So right here, we need to declare that apparently. So
Yep.
I'm going to try copying this one. I'm just going to look if it's got to be inside any braces anywhere, and it doesn't look like it. It looks like it's just standalone.
And that
So
would be
after
because
putting your load, go ahead, Dave.
no, that you would need to.
That
It does not need to be inside anything because it's not executing it. You're just simply
No.
defining RTC to exist.
Right.
And you're
Right.
telling
So
it
I
to
just kind of
use the
spread this out so you guys can see it. Here's the include that we put in first. So that loads the library, and this will execute kind of or tell it to
set it up. It sets
Right.
up RTC. And
Yeah, it's an instance of the library.
Yeah. So I'm going to hit save again and one more time, see if we can successfully compile. Anybody else playing along with this? JD, have you gotten past this, or did you try putting that one in yet?
No, not yet. I'm trying to find where to get it. I'll just hand type it.
Okay. Well, this is looking better. We got about 3/4 of the way through compiling. So the code is, if you want to just hand type it, is DS3231, then RTC parentheses SDA comma space SCL parentheses semicolon. I'll highlight it on my screen so you can, if it helps. If you can't read it, let me know, but that's where you want to look. Hey, done compiling. Looks like we were successful. So I'm going to go ahead.
You might want to change your time. Correct your
Yep,
time.
change my time. So we have 8:44. I'll just make it 45. Hit save and push upload. And this time it should go quicker because it's already compiled once. There we go. It's almost done already. Uploading, done. Ta-da. Okay, so it didn't fail. That's a good sign. So what I do now, following his instructions from earlier on, is now you re-comment these 3 lines. I'm just going to do it quick to test it, and then we'll go back and get you guys all to walk through the same thing. Hit save.
I don't see this. Am I missing the thing where it says it actually uploaded it? The red, usually it's red text in that box.
Oh, I already went past
Oh,
and hit save, so now it's why it says done
okay.
saving.
Okay.
Oh, I didn't. Yeah, okay. So I'm gonna upload this time again. So compiling sketch. You have to watch carefully.
I didn't see the section at the bottom where it.
Then uploading. And then done uploading. That's all I ever get right there. See where it says
Okay.
done uploading.
I get different results. I probably have my configuration set differently.
Okay. So now if I open my serial monitor, because basically what I did is I programmed this time and date, I commented it out, and I reran the whole thing, and all this whole thing that's left after you comment that out is to load the library, begin the serial monitor, and begin the real-time clock so that the serial monitor can read it. So if I go to my serial monitor, turn it on, I should see it ticking off the seconds if this thing worked correctly.
You need to change your baud rate. He's got it set to 15 or 115/200.
So 9600, I'm guessing.
Well, you could either
let
change
me see
that to 9600 or you change the window to 115/200.
Let's see, where's
Up. Serial monitor's up one more.
right, but where's the baud rate?
Oh, it's on the serial monitor window. Click that right in the lower corner there.
9600. Okay. So the point is, for you, those of you watching, if you look in the code, when it begins the serial monitor, he's got this programmed at 115/200 as the baud rate. Typically, like mine is set for 9600. And a way to find out what you need to set yours at is to open your serial monitor and look right down here at the bottom. So there's two ways we can do it. Either I can go back and leave that code and change my baud rate on here to match, or I can change the code to match what my monitor's set at, which is what I'm doing. So I'm just going to close that. So I changed it to 9600 to match my serial monitor. I hit save and upload again. The neat part is I don't have to worry about the time and date because I already have that set. And with the battery and the real-time clock, until I change it again, that should stay. So it's done uploading.
But you'll see you have nothing in loop, so you're never going to see anything on a serial monitor. It's not displaying anything.
So we need to, yeah, you're right. So we need to do the next sketch.
Yep.
Or we could just do print, print command for the serial monitor.
You still need to pull the time out of the clock.
Okay, yeah, you're right. So let's go back to the mechatronics, or before I do that, what we'll do next when everybody's caught up is we'll go to the mechatronics page and download a sketch where it can actually read the time now that I have it set. So sharing for a second so I can see what you guys are up to. I just like looking at the tunnel of doom there. Okay. How you doing there? Is he still with us?
Who's that?
JD? You're muted.
Yeah, it's not compiling. I can't get it to compile. Heili's tried, stuff.
You want to share your screen? We can take a look at it and see what might be your problem.
Now notice this. I had to reinstall the whole Arduino stuff. My hard drive had crashed, my boot drive, so I rebuilt it.
Oh.
So I installed while you were starting the show. So.
Okay.
Oh, that hurts.
Yeah, I know.
Yeah.
Tell me about it.
It's pretty good that you're able to do it that quick.
Well, no, it crashed last Thursday. Anyway, let's see if I can screen share. Are you able to see that?
Dave and Chris.
Bigger.
Yeah, I see it.
Okay, now I do. Whoops.
Let's see, serial begin.
Dave.
I'm looking.
Okay, I'm seeing Dave's screen, not JD's. Oh, let me just
Do you
click
have
on it
mine?
that maybe.
You probably have
There
mine
we go.
just clicked on the white square on the bottom.
No, I didn't have any of them clicked, and then it was
So
some
if there's
reason
any
it picked
typos,
yours.
blame Haley. She's the one typing.
Hi.
Okay, so I see the
He doesn't have a void loop.
yeah,
it
you
has
gotta
a
add
void
your
loop.
void loop.
Ah, okay, go ahead.
Where at?
Hit enter.
So if you don't know exactly what you need to do, just start a new sketch and copy it out of there and paste it in.
Otherwise, it's quicker just to type in void space loop, open and close parenthesis. There you go.
Okay, so let's hit Control S. That would help.
Yay.
Computer is quick. I compiled instantly. Mine's so dang slow.
Well, I used to have an SSD. Now I don't.
Yeah. Okay, so it uploaded successfully. Now comment out your.
We need to change the clock time.
It
Oh, yeah,
is
if you wanna do-
52.
Okay.
And then comment out those three and reload it is what they tell you to do. I don't know why, but
JD, are you on the East Coast?
Yeah,
Okay, then 21 is
that's
fine.
why the hour difference.
and then go ahead and upload them there. All done. Okay.
Hold on.
So anybody out in YouTube land working along that needs to see, needs a little time or wants us to help, we can do that. Otherwise, we're going to move on. So just screen now or wherever hold your RTC. Back to the how to mechatronics page. And JD, when you watch how slow this thing is, that's what you get with a $250 Walmart special from 3 years ago.
Well, I was able to install the whole IDE while you were showing the websites.
Stop it.
And that's for the
Okay.
mechanical drive.
This code, I actually need to go back to the others now that I think of it, because this code was, and actually we could jump to this if you want to go ahead and do some hardwiring. What I wanted to do was, last time was hook up the LCD to the real-time clock and get to see it right on our LCD rather than a serial monitor. We can go back and just try and see the thing on the serial monitor, or we can just go right ahead and add a little wiring and see it on our LCD.
I say,
So if I go back to the original website, the Tronics stuff website, if I remember right, let me see. This is once you have your RCC module, enter and upload the following sketch. See, all this stuff in this sketch right here is taken care of by that library. Well, that library is everything except for this, the serial print stuff down here. Oh, apologize here. I'm not screen sharing, am I? So let me go back to screen sharing. I'm talking and not showing. So if you go to back to this Tronics site, Tronics stuff website, the first one we went to, and you scroll down, you're going to see a bunch of code in here. Now, most of this code is covered by that library. Other than when you get down here to all this serial print stuff, that's where it's actually printing it out to the serial monitor. if you want to see it's, you know, serial print, which day of the week it is, what the month is, and what the time is. But for the most part, everything else above this was actually library. So that saves us a lot of coding just loading that one library. You notice the only library they're loading in this one is the wire. Oh no, I covered it up. Scroll up. There we go. So the include, wow, stop it. Include wire.h, that's for the I2C network. But the bulk of this code below that is all in, because we loaded a DS3231 library, we can skip the majority of all of this coding to the point where we actually just want to run this on our display. So we got two options. We can go ahead and load this whole thing and just try and see it on the serial monitor
Actually,
without a library, or we can just go ahead and hook up our LCD. It's only a couple wires and we can go ahead and print it on there right away.
well, I got an idea here, Chris. Hear me
All
out.
right.
Copy your serial print, copy one of those serial print lines.
Okay. Hang on 1 second. I just said throat was getting dry. So let's do
That's fine.
serial print second, or here,
Sure.
serial print day of the month.
Sure, take the semicolon too. Go back, copy that, and paste it in the inside of the loop for your Arduino sketch. Yep, right there. Now, highlight the day of month, comma, decimal, and delete that part.
Oh,
And,
all of this?
yep. Just delete
Okay.
that. Now go over to your how to mechatronics one.
Oops. Back to here.
That's your other tab.
Yeah.
And if you look right down there, you'll see one of those that says lcd.print RTC get time string.
But we'd want to do serial.print because we don't have our
Right.
RTC hooked
Just
up,
copy
our
the
LCD hooked
RTC
up.
get time string part.
Oh, and paste that in place of it.
Yeah, and take, yep, right there. That's it. Copy that, paste it inside the parentheses in there. Yep.
Okay. So let's test it and then I'll come back and let you guys see exactly what it was so that you can do it too. So let's just try it. Save. Oh, you know what we should have done is put a delay, because otherwise it's just going to stream.
Yeah, delay
Yes.
1,000 milliseconds.
Yeah.
Delay
After
1,000.
Come on, baby. I'm uploading. Let's just take a look. If I open my serial monitor, it should be scrolling really fast. The actual, it's not doing it a line at a time. It's going horizontally. So
Okay, we could fix that too.
notice it's just, if I scroll back, it just keeps adding in perpetuity on one line.
JD, what is that? Is that
I don't know
print
if that's-
NL? Is that what you would want to do?
I think if you change it right in your serial monitor, I'm not sure, but
No, you would
Can
have
I
to put
turn
like, I think it's print NL. Let me do a quick.
I think just the delay will cause it. Let me try that.
It won't.
No, you got to use print
No.
LN or
Print LN
print
for
LN.
line, because otherwise you get every number next to each other.
yeah, or like Dave's saying, you can use a /n.
Yeah.
Yeah.
Either way.
So how come we haven't had to do that? You know, other than with the
You've
serial
been doing it.
monitor vertically when we haven't had a commit. Is that
I think you've been doing it. You just didn't notice it.
okay?
So it would be serial
So-
print LN.
Yeah.
Oh,
With
add it to this one or an
Yeah.
extra line?
No, just
Add it,
add
you
it
can
to
add
that.
it as an extra line. Do it there
If I
too.
take
Yeah,
serial
I see
dot
where you're
print,
yeah, that's fine, right? Like that.
fix it, LN.
Yep. Put in your loop. Put in your delay before you compile too. Yeah, you could do that, but then you have to print a space or something like that. So open paren. You have to actually
Do
print.
delay.
Now that won't compile as it is. You'll have to finish your print ln command. So you have to put something in
What do
there.
I need to put in there?
Just put in an open parenthesis. Start your open parenthesis just like the line above it.
Oh, and put this
And then
info
put
in
it
there.
in ticks, put a space character or something like that. Start open tick, space, close tick, and then a close paren and a semicolon.
Chris, I just use serial.print line, and it's working. Print ln.
Oh,
Yeah, I thought you had to print something.
No,
you're breaking up. I'm only catching serial print. See here.
so it's just change the first line to print ln, and then you don't need the second line.
Get rid of all this. Does that look good?
As JD said,
Yeah.
go on the first line where it says print, change that to print ln, and then get rid of the
1
second
second,
line.
I got it. Having some technical difficulties here. Stand by. Okay, can you guys hear me?
That's better.
No. All right, can you hear me?
Yep.
Okay. Let me know if I start feeding back. I had to ditch the microphone and the headphone. Oh, let me bring back, reshare my screen and bring back the thing in. So where I left off was I had just added the ln, so I got serial.print ln, and then that string that you had me insert. Yeah.
Yeah, that should work. Now put in your delay statement.
So delay. Oops.
What?
Spell.
If you delay 1000, you're just delaying for 1 second, and then you're printing the new time.
If you delay for any
Do I
other,
need
you delay for less than a 1000, that means you'll see possibly a repeat of a second instead of each individual seconds on the clock as they display on the monitor.
All right, so I'm going to go ahead and save that. And if it all works right, I'll kind of re-explain it all. I know we've been jumping all over and with the technical difficulties, but for the benefit of the people out in YouTube land, if this actually works, we'll go back and cover what we did. It hasn't bombed yet, but it's still compiling. Okay, let's take a look at the serial monitor. Hey, there it is. Look at that. Every second. Adding, adding, adding. Nice. So now besides the time, you could also display the date, the month, the week, a year. So that could come in handy somewhere along the line. You want to write an Arduino program to have it check something a day or something to, you know, check a sensor, something like that. You could do that. Have it spit out a display of something once every minute or once every hour or once a day. You could have it do that. So all you got to do is go out like this and then have it execute whatever command you want if it meets that time or at a certain time. So possibilities out there. That's with the real-time clock. You know, we could even do something after something happens, like a train goes through, then you wait 1 hour and then execute some other command. You know, whatever your imagination is. So kind of, you never know. Imaginations run wild and cool things happen. So, all right. So that worked successfully. So what we did was we got the serial.print ln, which tells it to, in the serial monitor, print. And what it does is this RTC get time. What does the STR stand for? Anybody know? String. String. Okay. So get time string. So what it's doing is actually just going out to the clock, asking for the time, and printing it. Delaying a second, going out to the real-time clock, asking for the time, and printing it.
I would
That's
bet
pretty
anything
much
if you change that to a get date string, it would print the date in there.
more than likely. Maybe even week or find out.
And
Say,
you could tell that it accepted it because it highlighted it in yellow. So that is a valid command. And they might even have one get date time string.
oh yeah, you can. I think you can do any of the combinations. We'll go back and look at those two websites in a second. You'll see that there's all different things you can pull. Any combination of seconds, minutes, days, weeks, months, and years. Different formats, 12-hour or 24, I think. You know, this programming was done in 24-hour, but it'll certainly display in 12-hour if you'd rather. So, just did that. So. All right, let's open my serial monitor. And nothing is, oh, there it is. That's going to, every second, it's going to display the same date over and over and over until the date changes at midnight. Or until I shut off my Arduino, whichever comes first. There you have it. I would wager you could copy this line. Just experiment and see. Paste it up here. Save and upload. Should give us the time alternating on lines every second.
If you wanted to, you could get the date and time on one line by removing the ln on the first line there.
Yep. Then it would be a matter of, can you put spaces in there just to spread them out a little bit?
Sure. You just do another print line.
Print line with nothing in it, or quotes
Yeah,
and empty quotes,
yeah,
or something.
like
Spaces
you originally
between
did with a space within ticks to denote a string of
So
a space.
now you look at my serial monitor. That's what it's doing. It's giving me every other line. Date, time, date, time, date, time, date. Every second. So now let's go ahead. Since we got that working, rather than looking at the serial monitor, I really want to, we've burned up a whole lot more time than I thought already. So go ahead and just try and do this hooking up our LCD. Did you have the trying to remember, did you have the I2C backpack on your LCD display?
I do, but I need to re-download library because I lost, remember, because it stores them in the on the C drive.
Oh, yeah.
So now I'm storing the libraries on my data drive.
So let me get the name of that library for you. I think it was just Liquid Crystal. And you need the wire. Well, the wire comes with the IDE, I do believe.
Yes, it does.
Yeah.
Oh, I'm going to go to, I think I'm on the wrong website. Here we go. Go to the How to Mechatronics website. And somehow I ended up on the wrong page, I think. Oh, here it is. I just need to scroll back up. So here we have the real-time clock and the code to go with it. So is the library, because if you see the include liquidcrystal.h, so I would think if you just Google liquidcrystal.h, you could find a place to download it.
Yeah.
Unzip it into your library folder and it should be good to go.
All right, working on that now.
Okay. So while we do that, I'm just going to review and look at how we're going to hook this up. It's very simple. We had a sketch here somewhere, a fritzing diagram. There it is. Okay, that's the one for strictly the real-time clock. Oh, I know where I had it on my my OneNote that I was showing you before, I think. That's the one I want you to see. So they both use the same thing. They both need the 5 volts. They both need a ground. They both need an SDA and an SCL wire connected to analog 4 and 5. So I'm going to just grab a breadboard just to make it easier. And so I'm going to unplug my Arduino for a moment. I'm disconnecting. In fact, I'll just go ahead and stop screen sharing so you can camera. Can you guys see that?
Yep.
So what I did was I pulled out my SCL and SDA wires, the ground from the clock. And you can see I got a breadboard and it's got junk in it from last time. So I'm going to go ahead and find my other breadboard that doesn't have stuff plugged into it. There we go. So the neat thing about these pinouts facing on the breadboard, really take my clock and one of these pins is a little bit off. You may find that some of yours are not quite bent perfectly or got bent somehow, sticking a wire on it or something. Get that right into the breadboard like that. And the long in row is the long way, crossways. If you got your backpack, you should be able to do the same thing. Maybe not. Not going to work.
You could probably, if you're careful, you could probably plug them in the same row. So you see that.
Well,
Yeah,
the problem I'm having is there's the this edge on the PC board.
Yep.
Is the ends of the pin, so I can't push it down in.
So you're going to need male to female pins.
Right. So that saves me a couple wires anyways. what I can do then is I can look on read your numbers, or you read your tags on there. I'm just going to grab some wires. Start with the power first. We know we need Arduino power to the breadboard. 5-volt. I'll go ahead and just put it in the, and if I can find my black wire, there it is. Now these are male-to-male wires with the 2 male ends. I'll do ground to the negative rail. Going back to my LCD board now, and take one of these male to female wires. Looking for the black one, there it is. Ground to the ground on my real-time clock, which is the one on the end right here. One more wire to jump it back to the rail, or better than that, I can skip sending the power to the rail and I can just put it right into that same row. So basically, let me just clear everything out to show you, because it will just be repeating the same thing times. I got ground running from the ground on here to the ground pin on here in the same row, and over to the Arduino. So that puts both of these devices on the same ground to the Arduino. Now I'll do the same thing with power. I'll take female to male, run it from the VCC on my LCD display to the VCC on the real-time clock. And then I'll take my male to male wire, run it from 5 volts on the Arduino. I didn't hit my ground correctly there. To the VCC row on the real-time clock. And we'll just repeat that again. We'll do the SDA to SDA. And then SDA to analog pin 4, I do believe, right? Should start getting to know that. We've done it a couple times already, so double check before I fire this up, but I'm thinking SDA goes to analog pin 4. If somebody else has time to look that up and verify it for me, that'd be great. Otherwise, I'll do it in a minute.
No, you are correct. SDA is A4, analog 4.
Okay. And last but not least, we'll play to the SCL. And analog pin 5 on the Arduino. Looks complicated, but it's not. It's just repeating the pattern 4 times. So let's see if I can get you a better view of all of this mess. So that's pretty much back to screen sharing. Then I'll put up the fritzing diagram one more time so you can see. So they just did it a little bit different. They ran it to a rail Arduino. See, this one has power to the rail. This one has power to the rail. And then there's one.
You're not sharing your
And that-
screen, Chris.
Oh, okay, here we go. I'm stuck, not sure. How's that? Tunnel of Doom and Fritzen diagram.
There it is.
What they're doing is they're using these common rails and an extra wire to accomplish the same thing. So here's the VCC from the clock to the rail. Same thing from, or I should say from your backpack on your LCD to the rail. Here's from the clock to the rail, the Arduino. The ground, and then they a common connection back. So it's same principle, different set of holes. Now, if we did everything right, are you caught up, JD? You guys got her set, ready to do some code? Must be muted, JD. Nope. Is he still there? Okay. Well, I'll move on without him then.
Yeah, we're just trying to wire it.
Okay, I was just checking if you were caught up to me before I go ahead and.
Not quite,
Okay.
but we'll try to catch up.
So while they're catching up, I'll just kind of go over this code a little bit for the people in YouTube land. Let's just kind of take a look at it and see if we can understand what it's doing. You usually do. So starting at the top here, they're loading. There we go. They're loading the DS3231 library. That's the one we added to our library earlier. Then they're doing the liquid crystal library, which is our LCD. Then here's that command we had to add before to get our real-time clock running. And then they do the same thing with the liquid crystal library. They set the parameters for that. We go ahead to our void setup loop, and it starts the real-time clock, RTC begin, D with the LCD begin, comma 2. So means that it's 16 characters, 2 lines. Should be good on that because that's the kind of display I have. JD, if you have something other than a 16 by 2, you would have to change. Same
No,
goes for anybody.
Yeah.
You know, if you had a 20 by 4, you would have to change these numbers here to 20 by 4. Or whatever your LCD is. And that's it for setup. And then we get to the void loop. To set the cursor at 0, 0. Display. And then it says to print the word time space. Then it does a command that we just learned, which is to print a real-time clock. But you notice, now this is something I just learned from Dave, there's no print ln in here. So what it's doing is it's time, and then right after that, it's putting the actual time. So it should display on one line, the word time, whether it's 20 dot, you know, in 24 hours time. It should actually display that all on one line. Because then you notice the next command, it says set cursor 0, 1. Well, that's telling it to put it in the first position on the second line. Last time, this 0, 1, and this 1 stands for line 2. Little byte world, 0 is the first and 1 is the second. So then
Us programmers are weird that way.
Yeah. So then after you move down to line 2, it's going to write the word date with a colon and some extra spaces. Go out, read the date from the real-time clock and type it right after that. No ln in here, so that means on the same line. is 1 second or 1,000 milliseconds, and it repeats over and over. So every second on your LCD display, it should tell you the time and the time on the first line, the word date, and the actual date on the second line. All there is to this entire sketch. Now, when you compare that one, that really goes to show the benefit of that library. I mean, we're not only doing the time and date, we're adding an LCD into the equation, a whole nother piece of hardware, and we got 30 lines, of which most of them are blank lines and brackets and comments. So that's really so cool that way.
You're really looking at
Copy
only
the
8 to 10 lines of real code.
So I'm going to copy this sketch. Scrolls down and make sure you get the little curly brace on line 31. Control C to copy to my clipboard. Go to my IDE. A new sketch. And paste it in. I'll make this full screen for you. There we go. I'm going to go ahead and upload this. And it's not going to work because I unplugged my Arduino while I was messing around with hooking it up. Failed, which is fine. Plug it back in. Try it again. Because I plugged it in the wrong COM port. So now I get to wait for it to fail again, and then I'll upload one more time. I stuck it in a different USB port, the USB port that had the receiver for my wireless headset that went bad about an hour ago. Well, this is looking good. Even though it failed, it got past the point where my LCD actually lit up. Even though it's still compiling, uploading it, or before it failed, it actually got to the point of. And this time I recognized the COM port if I switched it fast enough. It hasn't failed yet, so that's a good sign. And like I said, my LCD has lit up with no words on it yet, but while I wait for that.
Yeah, I think that the liquid crystal is a pretty large library. That's why it's taken so long to compile.
So I'm just going to close out a few things in the meantime, just to see if we can get some resources back in this computer.
Now,
Hey,
one
Chris,
thing
real quick, I just want to confirm that we've connected this correctly. Where was that diagram at?
Oh, I can show you. That was something I had on in my OneNote. I'll have to reopen it and share it.
Because I'm looking for it on the website. I'm like, okay, it's not there.
No, it's not on the website because that was one that I found somewhere else. There we go. Can you see that? What you're doing is you're tying together the similar pins from both your LCD and your real-time clock, and then running them to your.
Yeah. So I know we've done on the ground rail and the positive rail. So Heili's done that, connected all those together to the clock and to the LCD. I guess what is this?
So the SDA, you just pick a blank row somewhere and use that as a rail, and then you pick a different blank row and use that as a rail for the SCL.
And so they don't go into the SCL and SDA in here on the top, but they go to what, A3 and A4?
A4 and A5.
A4 and A5. So which one is A4?
SDA is A4.
Yeah, SDA is A4
Okay.
and SCL is A5.
So we have to take these and connect them to
All right,
here.
I'm gonna scribble that. SCL is
So you want to do the equivalent of taking your two SDLs from, or SDAs from your two devices, twist them together, and then send them to the Arduino.
Yeah, got it. Thanks.
Okay, so I'm done uploading. And I'm not seeing anything right now on my display other than the fact that it's lit up. So let me take a look. I'm going to re-upload it one more time because there may have been a failure because of my pulling the USB while it was. I mean, it finished, but it doesn't mean it finished correctly.
Well, the one other thing I noted, Chris, was that you're using a different LCD library than you used last week when we were or last time when we were doing this. You were using liquid crystal underscore I2C last time.
Yeah.
So you
So it's
would
not
need
defining.
yeah, you might need to change your include library to be
The other thing
underscore I2C. And then you'd also need to change that main liquid crystal command.
So let's explore that while we wait for JD to get caught up. Oh, come on, computer. There we go. Now what did I do? All I wanted was a window. Start. Let's get back to here. Let the thing finish doing what it was doing. JD, are you okay with that diagram if I close that out again? Throw it up there one more time for you. And I'm just gonna flush that. There we go. First, I wouldn't get any. So I'll go to Documents, Arduino, Libraries. New liquid crystal is name. Question is that the, so liquid crystal underscore I2C? Is that what you said, Dave?
Yeah, I have it up in front of me. I can read it off to you.
Okay, so as long, I just want to make sure that underscore is correct.
That is correct. It's an underscore I2C.
All right, so those of you who worked along last week with us and we used that library might want to use it again. So what I'm going to do is I'm going right here into the include library statement. And I'm going to add the underscore I2C. And you notice it turned back to orange, like Dave said. So we know that that was correct because before that it's black.
Yep.
The second I spelled it correctly, even just making a small c isn't good enough. As soon as I make it a capital C, boom, it turned back orange or yellow, whatever color your screen shows, you know you're good. So now I have to come down here and do the same thing, right, Dave?
Yep, that is correct.
So underscore, you notice it turned black. I capital 2, C capital, it turned orange again. If I spell it wrong or you don't even use the correct capitalization, it's.
And for the parameters of that LCD, I had a different set of parameters. Now, I don't know if you remember your address. You had to put 0x and then your address in there.
I think mine was like 03X, where the other one was 02F or something was. I can open that sketch.
Yeah, I recommend open go to recent. You might find it there.
Right. April
Probably that one,
19th.
yeah.
That sounds right. Huh? Hello World I2C. That's probably it right there.
Yeah.
All right. So I'm going back and opening a sketch from our last show. And remember we talked about, so mine is the 0x38 versus
Yep.
whatever you had, whatever one you had to add to get yours to work last week or last show. So what I'm going to do is just copy basically this whole line right here.
Yeah.
In fact, I'll even throw the comment in there. I'm just going to replace this whole line with it. And just to make it a little neater to read, I'll add that space in there. Hit save.
It didn't actually replace that line though.
Oh,
You didn't.
all right, let's try that again then. Control C, Control V. There we go. Oops, that was the same. Yeah, that's the one we're on right now. So there we go.
I got to ask you a question. When I did the parameters last week on that statement, I had like more numbers after that. Did
Right,
you only
that's
have
correct.
yours with it? And so
There's two different addresses they gave as a possibility, and the default address is the one that you have that certain
no,
versions would work with.
but there were additional parameters after the
Oh, there.
38. Okay, no, that's fine. We could give this a try. Your liquid
Well, you
crystal
can
though
take a
is
look
not
real quick too.
orange.
Let me just look at the other sketch that I did on April
Yeah.
19th and see what that one says. So
Yeah, so you got a whole bunch of numbers
yeah,
on
you're
there.
right.
That's what I
All
was
right, so
talking
let's try
about.
that.
And interesting, your address is different there. 3F there.
Yeah, because if you look right up here, it says to set it as OX27. A few use address 03F.
Yep.
That was the one that I needed to make mine work. So
Yep.
actually that Hello World sketch, I don't think we actually even did that one. So that's why that stuff was wrong.
Right.
We would have never got it working with that. So
Agreed.
good catch. Thank you guys. Go back in and oops, I'm gonna close. That's the stupid Hello World sketch. There we go. And here's today's. So I'm gonna replace this one more time with the one that I know worked on the last show. So my address is 3X, and then it's got a bunch of parameters to go with it. Save and upload. It's amazing because even though it looks complicated, even a hack like I can figure this out, and just using a little common logic, you know, once you get a feel for the logic they're using, you can kind of fumble your way through. A little help here and there, you know, if it wouldn't have worked, then I would have probably looked into that, because it does kind of tell you at the bottom, if you scroll through it and read through it, it kind of get an idea where it failed. Okay, here we go. I bet you I'm getting an address conflict now. To see the redefinition of DS3231 RTC.
Hmm.
And it highlighted that line. Oh, where
Yeah,
did
your
that go?
liquid crystal changed. Yeah.
How did that get undone? Unless I somehow did an undo. You all saw me put it there.
Yeah.
I wasn't imagining things. Good catch, Johnny. Eagle eyes. All right, let's try it again. But the weird part is that it's tagging us with the other library. It's telling us that that one failed. That's kind of what it seemed like from that message anyways. Yeah, it's not like in the real-time live or DS. So we have the include statement, DS3231.h, include the liquid crystal. I wonder if there's an address conflict with this stuff right here. Because we're running two I2C devices.
Chris, mine compiled without those numbers there for the addresses.
It did. So if I knock off all of this stuff.
Yeah, and it doesn't like that positive numerator type.
All right, let me give it a shot once. So yours compiled, and did it upload to or just compile?
Uploaded, but we got blank on the screen though, on the LCD.
Yeah, because what those numbers are is that kind of tells the I2C how to send data to which pins on the LCD.
Right.
I had it
So
working.
it's kind of neat.
Now you're using I2C library. Is that what we used last time?
Yes.
Yeah.
Okay, I'm just using liquid crystal
So
library.
you had the blanks. Yeah, so I had the same thing, JD. Mine lights up with a blank screen. Oh, liquid crystal library. That's why we're trying this I2C library. But I'm going to do one thing. I'm going to grab a screwdriver and adjust my potentiometer because it looks a little on the bright side.
Yeah, let's do that.
I wonder if that could be what's causing us the problem. Maybe it's actually there and it's too bright for me to see it. Still nothing there.
Yep.
Okay, so let's go back. I went back to the because when I look at I went back to the mechatronics page, sketch, and lo and behold, there's a bunch of values in here, but there's no address.
Yeah, that's a different library though. Liquid Crystal is a different library than the Liquid Crystal I2C, so the parameters will be different. You need to use if you use the
Unless that's for a
I2C library.
non-backpack. Is that a non-I2C version? Is that what that's for?
Yeah, that one probably is a non-I2C.
A non-backpack version, if you will.
Yeah, I agree.
All right, so then we're kind of stuck here. We gotta
What was that error that you were getting?
find the right parameters to. What was what?
It sounded like an address conflict between DS 3231. Did you find? Does it say anywhere what the address is of the DS 3231?
No. Okay.
Right.
So I got an idea. I'm gonna take my sketch from April 19th that I know worked. First, I'm gonna close it in case I accidentally changed anything on it. And I'm gonna use that as cannon fodder for a new sketch. So if I go to open recent, the April 19th, that's when our last show was. So if I take this sketch and upload it, it should work because even though my real-time clock is wired in, it should work. Was because this was working when we shut her down last time. So let me see if we can just add in the real-time clock to this sketch and make it work. By loading the library and loading the code to read it and get the data and print it. instead of trying to incorporate the liquid crystal into the real-time clock, we're going to incorporate the real-time clock into a known working liquid crystal sketch.
Ah, that is true.
Oh, that could be a problem. Because that
Yeah,
it was failing at the first library, which was an I2C device. So that could very well be the problem right there. In fact, while I wait for this to compile, butchered up a couple times already. I should just reopen a new one, copy his code. Because, you know, the power could, the display could be lighting up just because it's simply getting power. Doesn't mean it's getting any commands via the I2C. It means the voltage and the ground are correct. Without the wire.h, maybe it, why we're not getting anything on a display. I like that thought. But we'll come back to that in a minute if this doesn't work. So this one is still compiling. Come on.
actually, that makes sense. It makes sense because the other library, the real-time clock library might be including wire.h, but liquid crystal won't see that. So I think that's
But it was my real-time clock library that was failing.
Yeah,
So
sometimes errors aren't exactly what they say they are. I'm sure JD can agree with that. Sometimes
That
you
could
have
be the
to.
case.
If you're caught up and try and go ahead and just do the include wire.h as your first include and see what happens while we wait for mine to upload on this other sketch. Okay, there we go. So mine just got done uploading. Immediately my LCD flashed 3 times. If you remember, that was part of what it was supposed to do. And then now I just have to retweak my potentiometer because I couldn't read it, but now I can. There. Use serial monitor, type to display. So yeah, the whole thing that we did last time is working perfectly. So I know that this is good sketch right here. So I'm going to do a file save as and a little bit. Just going to do an underscore RTC1. Taking bits and pieces of this, we'll do the include. So I'll take my library and I'll put that right in under here. Then we need to take this line, which is where it was telling me it was failing, unless I accidentally knocked something out on that code, but that looks like exactly what we added before.
Yeah, it looks right.
So, probably right above this one. And then we need the RTC begin. Don't need the LCD begin because this one already has that. So I'll stick that in right here. After that, it should just be a matter of.
I think I know what it was. You have to do like an RTC end after when you pull in commands before you try and print it to the LCD. Because what's happening is when you do that RTC begin, it starts communicating with the real-time clock, and it can't communicate with LCD at the same time as it's communicating with the real-time clock.
Oh, so you got to do like right after
But that would not have had an effect on your compile though.
Okay.
That would have given you runtime errors, not compile time errors. We'll go through that. Let's see if you get a compile.
do anything else. You know,
We are getting real late though. Just so you
are
know.
we? Oh, yeah, we have to cut this off in about 10 minutes. So hopefully we can get something to work quick, because I'm just going to hit save and just see if it fails or not. Just adding in those couple things, loading the library, and then doing the RTC begin. What it's doing is it's initializing the clock, but we aren't pulling any data from it yet. File correctly, then I know I can just go down into my void loop, add some commands to pull the time and print it. One of the other things that I had going on down there. In fact, I could replace all of it, including this quick 3 blinks of backlight. Come on, compiler. Well, maybe now that I'm done building on the layout for a little while, I can accumulate some funds for a computer, since it's not all going into lumber and track.
Yeah, we'll get you a good one for a couple $100.
I do need to buy a little more track, but not too much. I have 2 passing sidings to finish. Probably about 15 sticks of Code 83 Atlas to finish it up. I think I burned through about five boxes of 25 sticks already, just on
That's quite a
mainline.
bit.
And I had a whole bunch before that, you know, all the yards and all that was done with stuff I already had from previous layouts. So that's 5 I had to buy. Well, it's compiling, but it's taking forever. So
Yeah, they're big libraries.
now we're loading 3 of them, huh? We're doing wire, liquid crystal, and the
The DS20,
yes,
32,
the real
31.
time clock. Yeah. It's getting late. I'm
Well, I
getting
think
brain fade.
the big one is the liquid crystal I2C library. That's a big library.
You know, if nothing else, we'll pick up where we left off, and by then a couple of you guys will have your real-time clocks and be ready to jump in here with us, and we'll have the code ready for you to go. That all you have to do is wire it up, and we can try it and do some. Because I always like to do code experiments once we get it running, just to, you know, dive into what each of the commands do. You know, it's always fun to change numbers and see what the effects are, and compile. And sweet. Let's go ahead and didn't fail. That's a good sign. Now let's see what it'll do if we. First thing I'm going to do is start pitching some of this code overboard. Flash the backlight.
Nope.
3 times, just to tell me that it's active. But I think I do need to leave this. Well, it should be on anyways.
Yep.
I'll leave it. I don't think it'll hurt anything, but we probably don't need it. So then the next thing it's doing is having it print hello world and hi, I'm your Arduino and all that stuff. So we can get rid of that. Don't need any of that. And then there's an LCD clear. I think we can leave that.
Yeah, that won't hurt.
Oh, no, we can get rid of all of this actually. This is all just
Leave the clear in there though. That way, if there's any remnants of a restart, it clears the screen.
Because you might get those block characters in there when you restart.
When we get down into the
good coding.
void loop, and all it was doing was printing, delaying, clearing, printing, delaying. If we take out all of this and substitute with.
Yeah, I would go back to that one you're on the Mechtronic, or no, on the The how-to Mechatronics page. If you go halfway down, there's a chunk that you want to paste in there.
This one right here, you know, the time and the date. That's all we really want to do. Time on line 1. So if I just copy this much of it, I've already got my curly braces left behind in the other sketch. See, I left them there. So all I do is paste that in between them. Curly brace on the end. I should be able to hit save. And if all goes well, this thing will work.
Agreed.
Because that void loop is just going to print the time and the date, delay a second, print the time and the date, delay a second. So go ahead and upload. Yeah, and see, it's a good thing I left it clear in there, because right now my has used serial mon type to display from our, that's still on there from our last sketch. So a lot quicker this time, which it is, because it's already been through it once now. Fingers, as we got, you know, before we really hit the 2-hour mark. So if this works before the 2-hour mark, that's awesome. Oh, look at that. Okay, stop screen sharing. It worked. A minute. See the seconds changing?
Hey, congratulations.
We did it. 0 to this in under 2 hours. Hour and 58 minutes. Nice.
Not bad.
57. That's lit. It's only 21:57.
And that's even the right time.
Yeah. That's because it's got the backup battery. I could turn this all off, unplug it all, rewire it all 3 weeks from now and turn it on, and it'll be the same. It'll be the correct time and date. That's the beauty of using the real-time clock versus the built-in on the Uno. Simulate the date or the time and even the date with some fancy programming, but every time you turn it off, it's gone. You reset it. So I guess that's, you know, that was my first question when I bought my kit, is what the hell do I need a real-time clock for? Pardon my French, but I started reading about it. Oh, cool, I understand now. It's all about having a clock that stays on time.
Would be really cool, Chris,
Regardless of
go get the date and time from the computer and pop it in there.
It'd be too hard to do for a programmer like you.
That's easy.
You could.
Any questions, or anybody out in the chat room that on YouTube that's got anything other, you know, it's got kind of off and whack, but hey, that's good. It can't always go right. Otherwise, we're not. This ain't a pre-programmed, this is how it's going to work thing. This is we're literally working through it from scratch, learning as we go. So I think that just goes to prove if we can do this, so can you. But if anybody out there has any comments, questions before we call it a night, or anybody on the panel. So, wow, I'm happy.
We're good.
It's really cool to see that. So, all right. Well, thanks for joining us. And now that I've got a little more time back in my life, I will try to post up within the next week what we're going to do on our next show. And Johnny, when is our next show going to be? Is it going to, are we still having one on the 3rd week of this month?
Yeah. Next show will be May 17th.
Okay, so May 17th, we'll see you again, and I will try to post within a week out on the YouTube Model Builders channel and what equipment you're going to need to do it. So as soon as I figure that out, I'll let you know. Otherwise, we could probably start out experimenting with this a little bit again. Or if you have any ideas, email them to me or post them up in the chat right now. Still going to work toward that speedometer. And I think this is a help now with the LCD and potentially the clock. But, you know, if nothing else, we could maybe make some fast clock or something else out of it, or timers for your buildings, whatever you want. But I'm going to work toward that now that I have a little free time to work up that speedometer and see what we got to do for that. It's coming, I promise you, but we'll probably have a couple shows before we get there. So,
All right.
and Johnny, take it away.
All right, Chris. Thank you for another good show. Definitely a learning experience. Greatly appreciate that. I do want to say we had a new fella in the chat, Life After Work. Yeah, if you want to catch up on some of the other Arduino shows, you can go to YouTube and then search YouTube Model Builders. We have a playlist for the Arduino where you can catch up there. Alrighty, so you want to go to YouTubeModelBuilders.com. There you can check the schedules for the Tuesday, Wednesday shows and the Saturday live show. Saturday live shows once a month, and Thursday and Saturday, those are at 9 o'clock Central, 9 o'clock Central, 10 o'clock Eastern time. Tuesday and Wednesday, those shows start at 8 o'clock Central and 9 o'clock Eastern time. They're an hour early. Be sure and click on the eMag and sign up for notifications when the e-magazine comes out. JD and his team do a great job on that magazine. It shows in each article, each time it comes out. Also, want to make note that the month of May and the month of June, the website, the schedule has been already changed, but we've changed. I had to change out the Tuesday shows. The fine scale show is May the 9th, and May the 23rd will be the track planner. Well, I had to reverse those two because of conflicts on scheduling there for the people in the shows. And then June, we've got another change too. That's up on the website also. Fine scale will be June 13, and there will be a layout tour, which is Chris's layout tour. This Chris right here, he's going to give us a full tour of his layout now that he's got it up and running. He's got an open house this month. He's been working to get everything working right, so you'd have a good open house. Hope that goes well for you, Chris. But anyway, we appreciate everybody coming in tonight. Appreciate everybody on the panel and all those in the chat. And we shall see you tomorrow night. We have the Thursday night show. So be sure and tune in then. That's going to be 9 o'clock Central, 10 o'clock Eastern time. Everyone have a good night. And we'll see you tomorrow night.